Welcome to this TSN Systems video. In the following program, we would like to give you a first impression of the TSN Tools software ecosystem. Please join us to help you understand what TSN Tools is about and how it can help you if you are a development or test engineer with some interest and/or challenges in Ethernet analysis, especially when it comes to time-sensitive traffic. TSN tools support many standard and specialized features in analysis and visualization of Ethernet frames, headers, and payloads on single links and entire networks. It can help with validation of ECUs and network switches in automotive development, especially in next-generation TSN-based zonal architectures. The benefit of TSN tools is a much faster understanding and troubleshooting of complex and time-sensitive communication systems with a user-friendly interfacing. Let's open TSN tools and have a look. On the left side, we find the asset library. At the top are connected TSN boxes, loaded projects, and sessions. At the bottom is a toolset of several filters and analyzers for both generic and very specific analysis. There are tools for standard Ethernet like MAC address, VLAN, EtherType, IPv4, IPv6, UDP, RTP, and much more. Additionally, there are lots of specialized features for analysis of time-aware systems like GPTP, QBV, AVB, flavored 1722 or 1733. For service-oriented architectures, there is extensive support for some IP analysis. Finally, there are many special features for Profinet analysis. At the bottom of the asset library area, you find all the graphical features, for example, the timeline, the line chart, the bar chart, the audio PCM chart, and the trace widget. For more details, we have videos for many special use cases in a constantly growing number. In the center, we find the workspace with Network tab, Data Flow or DFT tab, and the various self-defined views. In the Network tab, you can manage the work with TSN boxes. We will focus on this in one of the next videos. In the Data Flow tab, we define all the views and functionalities of the TSN Tools ecosystem using drag and drop. In the defined views, we realize the actual work. Finally, on the right side is the inspector window. This area is highly context-specific and generally shows the features and parameters of the currently activated element. When in DFT view, it can be used to set parameters of analyzers and graphical elements. When in a working view, it is typically used to display the drill down or dissection of activated or highlighted Ethernet frames. In this easy demo, we loaded a pre-recorded session of Ethernet traffic and a simple DFT. On the left side, we see the container for the session data. This can be seen as the data source. In the middle, we have an analyzer that extracts all frames of the session from the PCAP data. This is sent into a trace widget that displays data in a table just like Wireshark does. Additionally, we see a so-called timeline track that visualizes the Ethernet traffic in an oscilloscope-like timeline. This innovative approach of visualizing Ethernet traffic is extremely useful to identify patterns in a time-aware communication. Let's look at this view in a bit more detail. At the top, we see the timeline track that contains all Ethernet packets of the session ordered on a nanosecond precision scale. We can quickly zoom into the nanosecond scale, but also zoom out fast into a second or even minute scale. This can be a powerful tool to inspect specific areas and problems in the traffic. We can also move the position of the track in time. You might have noticed that the visualization of the data in the table below is following the scaling and position of the track. By selecting any Ethernet frame in the timeline or table, the inspector on the right dissects it similarly to how it's found in Wireshark. In the timeline, we can set markers and manually measure distances and delays between any two positions. In this case, we measured a distance of these two particular frames of approximately 250 microseconds. We now switch to another demo file that is slightly more complex. This demo gives some idea about specific analysis of QBV traffic, which is relevant in next-generation automotive architectures as well as industrial communication, such as Profinet. The DFT looks quite a bit more complex. The result of the view carries much more information. Let's see what we can learn. There are in total 11 timeline tracks. The top 4 show cyclic time-aware traffic, which is QBV shaped. The tracks below show GPTP traffic. GPTP, aka IEEE 802.1as, is the protocol that enables time-aware systems to propagate timing information throughout the network so that any node can maintain a local clock while being in sync with all other nodes on the network within tens of nanoseconds. TSN Tools has many features to analyze and validate the complex mechanisms that are needed to make this happen. Below the tracks, we see 6 graphical elements. We call them widgets. They show the following: interframe gap analysis of the QBV traffic before and after a switch, which provides a jitter analysis and metric for time-aware shaped traffic. Slave clock wander analysis. This module gives insights of the quality of synchronization of a GPTP slave node. Master clock wander. This judges the TSN box tap synchronization quality. The peer delay round trip time gives insights into the quality of the GPTP communication and therefore the workload of the GPTP stacks at the various end nodes. Finally, we see here in the table only filtered GPTP signals. Last but not least, let us show you a very different example that deals with AVB analysis in automotive infotainment. We can see various AVB streams with IEEE 1733 that contain RTP and RTCP packets. TSN Tools provides many specialized features to analyze audio frames and their respective timing information, such as presentation time budget, talker media clock jitter, and PCM payload visualization and analysis. Thank you for watching this video. If you need any further information, please feel free to contact us. Stay tuned for the next videos that will be released shortly. You will find them on our YouTube channel or on our website tsn.systems.